All right, we do start the class now. In the last class, we have discussed source shifting. In that, we have discussed how current sources should be shifted to reduce the network into its simplest form. Shifting is needed to reduce the given complex network into simple network. For that reason, source shifting should be used. In the last class, we have discussed how current sources are shifted. In short, it is called as a I shift. In short, it is also called as a I shift. So let us see one more example here. Here three registers, instead of registers, impedances are used here. Z1, Z2, Z3, and three nodes are considered: node A, node B, and node C. In between node A and C, the current I is flowing. So the current I is leaving the node C, and the same current I is entering the node A. If this is the case, it cannot be reduced to its simplest form. So none of the circuits are in either in series or in parallel, and current source is neither parallel with the resistors, and the voltage source, it is not in series with the any resistors. If this is the case, then it cannot be reduced to its simplest form. For that reason, I do shift this current source here. I do shift the current source, okay, in this manner. All right. So these two circuits are one another same. The advantage of this network is we can apply the source transformation. But here, this source transformation cannot be applied. So you can see here, compare these two networks. The current I is leaving the node C, that the same thing is happening. The I current is entering the node A, that is happening. Instead of one source, two sources are used here. At the node A, I current is coming and going. So net current at node B is 0 because of these two sources. Because of this a slight modification to the network, we can apply source transformation to reduce the complex network into its a simple form. All right. Next, consider one more circuit here. Here, node A to H are available, and impedances from Z1 to Z8 are available, and the current source I, it is connected between node A and node D. From node A, current I is leaving. To the node D, current I is entering. If this is the case, it can source transformation cannot be applied. There is no possibility of source transformation here, because current source, it is not in parallel with any of the resistors, or it is not voltage source, it is not in series with any resistors here. For that reason, we do go for source shifting. Instead of this, I do modify the given circuit here. Instead of one source, three sources are used here. Instead of one source, three sources are used. From node A, I current is leaving. To the node D, I current is entering. We have satisfied. These two are one and the same. These two are one and the same. And at node B and C, there is no current I. Same thing is happening here. The I current is entering, the same I current is leaving. So a net current of I at B is 0. Then consider at C, I current is entering, I current is leaving. Apply KCL at node C. The net current of I at node C is 0. So these two circuits are one another same. Advantage of this is we can apply source transformation. After applying source transformation, complex networks can be reduced to its a simple form. Then one more possibility. You can see here, it is one more possibility. Instead of 3 sources, 1, 2, 3, 4, 5 sources are used. Still, all the 3 circuits are equivalent here. They are one and the same. It is satisfying. The I current is leaving the node A and I current is entering the node D. At E, F, G, H, there is no I current. The same thing is happening here. Even though we have used 3 extra current source, at node H, I current is leaving, I current is entering. So that I at node H is 0. Same thing is happening here. Entering, leaving, entering, leaving. So that all these 3 circuits are one and the same. Have you understood the meaning of shifting of current source? Good. We do see the next source shifting concept, that is shifting the voltage source. In short, it is called as V shift. Consider a simple circuit here or network. Voltage V is applied at a node A. To that node A, impedances Z1, Z2, Z3, Z4 are connected. You can see here at a node A, positive polarity is connected. Keep that point in your mind. At node A, positive voltage is connected. This is the key point here. It can also be written as like this. It can also be written as. Okay. So, do you say that these two are one another same? These two are one another same. You can see here, this positive voltage is applied at this point, applied at this point, applied at this point, and voltage is applied at this point. Instead of one source, I do use 4 different voltages here. I do use 4 different voltages. They are, you can see here, this voltage V, positive terminal is connected at this point. Positive terminal is connected, all right. So that the one voltage source and 4 voltage sources all are performing the same task here. Advantage of this is we can apply source transformation concept, because you can see here a voltage source in series with the resistance. It is available here so that it can be converted into current source in parallel with the resistance. But in this case, that source transformation is not possible. You can see here, this positive terminal is applied this point, is applied at this point. You can observe here, the same thing is happening here. The disadvantage is instead of one voltage source, the 4 voltage sources are used here. But the advantage is this complex network can be reduced into its simplest form. All right? Any doubt? So V shift. Have you understood this concept? You should know how V shift should be applied and I shift should be applied. They are very much essential to convert a complex network into a simple network. All right. So still we do understand. We do understand in better way with the following example. Consider this. Consider this network. Here, source transformation cannot be applied. Do you agree? Yeah. So for this network, this concept cannot be applied here because voltage source is available, but none of the resistors are in series here. They are series, but before that, some modification should be done. Z1, Z2, Z3 are in parallel, convert it into equivalent resistance. Z4, Z5, they are in parallel, convert it into get the equivalent circuit. Then we will have a voltage source in series with the resistance. But that is not the concept here. That is not the concept here. The concept is use source shifting, later apply source transformation to make the complex network into a simple. This is the concept here. So I do a modification to this given network in this way. A positive voltage is applied to this point as well as this point. Do you agree? Yeah. So same thing is done here. I removed this voltage source. And it is the node B. To this node B, the negative is applied. Yes, it is there. Negative voltage is applied. Negative and negative, it is applied at node B. It is okay. And at these points, at these 2 points, the positive voltage is applied. I can say that these two are one another same because we have applied here to V shift. These two networks are one another same. All right. It can also be written in this way. It is also be written as in this way. So it is node A. Here it is node A. And to this point, for all these nodes, the negative voltage is applied. Is that right? Negative voltage. Positive voltage is applied to this point. Yes, it is there. Instead of 1 voltage, 2 voltages are used so that we can apply the source transformation. Instead of 1 voltage source, 3 voltage sources are used so that we can apply the source transformation. So whichever is comfortable, whichever is easy to reduce the next networks, so such V shift should be applied. All right. So moreover, we do solve examples on this concept.